A few days ago, you learned about factoring. You learned about factoring variables and numbers out of polynomials. And so what you would do is you would divide it away from each thing and put it in front of the parentheses. Then yesterday, you learned about a different type of factoring where you create two sets of parentheses from a polynomial. Today you're going to be learning about a few different scenarios, and so hopefully by the end of the class, once we finish this whole note paper, you will see all the different types of factoring that you have to do. Factoring normal quadratic trinomials. This is a review of yesterday. What is it? And so Emily is my Vanna White for the day. Emily, Vanna White makes hand motions like so, very elegantly, and she actually has a certain type of walk too. But you can do as much or as little as you want. What I'm going to ask you to do is for each section, write in a different colored marker.
Oh, I have to write?
Yes.
Oh, okay.
And so, what is it?
Wait.
I'm actually going to look at it and paraphrase it probably. And then I'll tell you what to write. So, what is it? It is what we did yesterday. It's when there are three terms. So go ahead and write in the far left side of the board 3 terms.
That is not the Wait, 3 terms? Okay.
Yep. In the form.
This is high.
And then underneath that write x squared plus bx plus c. There you go. That's really nice. What you may notice about this is that the leading term is x squared. There's no number in front of it. And so what is the trick? How do you do this? Do any of you remember? Suppose that all that a test said was the example there, x squared plus 3x plus 2. And Emily, we go ahead and write that example out there. X squared plus... Yeah, same color, yep. X squared plus 3x plus 2.
X squared.
What form will your answer be in? What will it look like? At all? It's from your homework yesterday. All the answers had how many sets of parentheses? 2. Right, 2 sets of parentheses under there. And 2 sets of parentheses. Leave them open. Yeah.
Vanna White does not ask questions.
And in both sets of parentheses, there was something in the front of it, like right here and right here. What was that?
X.
It was X, Tyree says. Something X in front. And then, what was next?
Vanna White.
What was next?
Plus.
Ellen.
It's find 2 numbers that multiply to the last one, and then they add to the point x.
2 numbers that multiply to 2 and add to 3. What are those 2 numbers? Sawyer?
1 and 2.
1 and 2. Positive 1 and positive 2. And so you'd fill in those blanks with a plus 1 and a plus 2. And so the trick is find a number that multiplies to 2 and that adds to 3. Factoring perfect square trinomials. What is it? And for this, you can write 3 terms.
That was cool. Put this pen on.
You can write x squared plus bx plus c. Again. And then underneath that, make a note that says c is a square. C is a square?
C is a square.
What does it mean for C to be a square? Lars?
This is a random guess, but does it have like 4 terms, like to the degree of it?
Yeah, so something is being squared to make that. So he said to the degree of 2. There's some number, when squared, that makes C. So suppose that C is 25. Will you write 25 next to wherever on there?
Okay.
So, and then write equals, what does 25 equal? What squared is 25? Nils? Pardon? 5. So 25 equals 5 squared. What's the trick? For the example, the trick is this. As you saw over here, we were looking for two numbers to fill into this blank and this blank. In this next section, factoring perfect square trinomials, you can write two parentheses with x in each one.
Can I just like go like this?
Yeah.
Parentheses.
No, write two sets of parentheses.
Oh.
Yeah. Don't write it out in words. I'm gonna try to be as literal as possible with you. You will write parentheses. Parenthesis.
Oh, wrong. And another one.
Yeah. There you go. And so you're gonna write an x in the front of each one. And then this number 5. That's the number for both sets of parentheses. So write a plus 5 plus 5.
Oh shoot. Oh shoot.
And so whenever you see a number at the end of your trinomial, so in that example, the last number is 25. You may see that it's 25 is something squared. It is a square. And if you see a square as the last number or the letter C, that means it could very well be a perfect square trinomial. And then what happens next may blow your minds.
Okay.
If you erase this parenthesis right here and you put a square sign right there,
It's the same thing.
it is the same thing.
Oh shoot.
All right. Factoring the difference of two squares. What is it?
What?
Two terms. Where b is 0. Where b is 0. And before I wrote, in a last one, I wrote x squared plus bx plus c. In this one, you're going to write x squared plus c. The b is missing. Why is the Why is the bx missing? Same.
Because 0 times something is always 0.
Yeah. When b is 0, that whole bx term is going to disappear. And so there's a few scenarios where b will become 0. And this is the trick. Whenever there's only two terms and it's x squared plus c, that means you're factoring. And so you can write parenthesis, and parenthesis, parenthesis, and parenthesis. And so what will happen in this is you'll have the two x's at the beginnings of the parentheses, but then over here, these two numbers, they're going to be the same number, but with different signs. So in the example, x squared minus 16, the trick is, 16 is the square of what number? What number times itself is 16?
4.
Sadie?
4.
So what numbers are going to go in here and here?
2.
4 and 4.
4 and?
4.
Not 4. Negative 4. And so there's going to be a positive 4 and a negative 4. And what happens is you're looking for two 4s, or two numbers, that add up to 0b. Multiply to c and add to 0b. When you do 4 plus negative 4, that adds to 0.
Okay.
Factoring ax squared plus bx plus c, what is different than the last ones here? What has changed? Ellen?
Is ax squared, not just x squared?
Yes, there's an a in front of the x, which means there's going to be a number in front of the x. So, what is it? You can write, there's going to be a number in front of the x. That's how it's different.
In front of the x.
Yeah, in front of the, the x squared. So factoring ax squared plus bx plus c, Now we see that there's an a at the beginning, which means, so what is it? That means there's a number in front of the x squared. When you see this, there's two ways of trying to figure it out. You go back to 2 days ago and you say, maybe there's a common factor that I can take out from each one. Sometimes that'll work, but not always. And so, if it doesn't work, you got to know the trick. So I'm going to have you write the example right here, which is 2x squared plus 11x plus 12. Now, the way that you factored trinomials yesterday isn't going to work quite the same here. You are still going to use one thing. You need to find two numbers that multiply to 12. So you can write the stuff under what is the trick. Two numbers that multiply to 12. And then two numbers that multiply to 2. And here's how you're going to write them. I'm going to write this out.
Right.
Look, that's how you write them. Oh, right there. Oh.
It's like a no.
All right, ready? The two numbers that multiply to 12 are going to go in this space. Shh, Ben. Are going to go in this space and in this space. The two numbers that multiply to 2 are going to go in this space and in this space. If you draw the eyebrows in your foil, what will happen is this multiplies with this to get this. This one multiplies with this one to get this one. But you don't know your middle term yet. The way to know if this is correct is to FOIL it to see if you get a middle term of 11x. So, I'm talking very abstractly now. Let's just do an example and maybe you guys will all understand. What two numbers multiply to 2, positive 2?
1 and 2.
1 and 2. Go ahead and put 2x.
There's 1 and 2.
1x. What two numbers multiply to 12?
1 and 12. 6 and
4 and 3. Go ahead and put a positive 4.
4. That's
And a
right.
positive 3. Alright, if we FOIL this, what are we going to get? Let's try this out. Emily, it's alright. Let's FOIL. Eyebrow, eyebrow, nose, mouth. Left eyebrow, 2x times 1x. What does that equal?
2.
It looks like a
2 x squared. Let's do mouth, 2x times 3.
7.
6x. Nose, 4 times 1x
17.
Oh.
plus 4x. And then right eyebrow, 4 times 3
12.
plus 12. Alright, we have a front term that's correct and a back term that's correct. Let's combine these and see what we get.
12.
Now, what is possible?
Like at 34.
What's possible is that I actually did the example, or I typed it up wrong. What I want you guys to do is I want you, on the stuff that I printed, I want you to change 11x to 10x.
Oh my god.
You may not do that on the test.
What?
Oh.
Why not?